Good evening, everybody. It's been a few years since I talked about RISC OS Pyromaniac, so things have changed a little bit. Right, so what will I talk about? I'm going to talk about how the project has evolved over the years, from being just a way to test things to providing new ways to develop and test software as well. I've split this up into a few sections. There'll be a short break between each to talk about the topics that I've discussed. Please do feel free to mention things in the chat or stick your hand up, and I will try and pay attention to that and try and catch any questions as they come up. If I miss you, then I'm very sorry, but do post in the chat as well. At the end of the presentation, the slides and a bunch of the links to resources will be made available as well, and I'll take some questions. So, let me introduce myself. I'm Charles. I previously was known as Justin, but I'm better known as Jerf these days. I've done a lot of work on RISC OS since the early 90s, patching and porting things, developing RISC OS itself, and most recently I created a new implementation of the OS itself, RISC OS Pyromaniac. I've always been a strong advocate for moving RISC OS forwards, and the work that I've done over the last few years is a testament to that, I believe. Oh, there you go. It's been a long time since I talked specifically about RISC OS Pyromaniac. I was here last to talk about the 64-bit, and we will talk a lot about that as well. But first, I'm going to introduce you to what Pyromaniac is, because this is always something that is worth recapping. It's been a long time. So it's intended for testing, debugging, developing, and experimenting with RISC OS interfaces. It's not intended for everyday use, but to make the process of developing and prototyping easier. It's written in a high-level language, Python, and it runs at the command line or within a window on Windows, Linux, and macOS. So what does that actually mean? It means that if you want to write some code and see whether it works, you can do that easily without having to use the RISC OS Classic system. There's no RISC PC emulator, there's no physical hardware you even need. You can use much more powerful systems. And you can just run your program and see how it works. And when you need to debug it, you can easily enable many of the options to make it easier to see what's happening. If you want, you can get a disassembly of every single instruction that's executed, or trap accesses to memory, or calls to functions. And that makes it a lot easier to see what's being done and what's gone wrong. If you're considering changing how part of RISC OS works, you can modify the interfaces to make it work differently. And because it's implemented in Python, changing that is a lot easier than changing the assembler. There's no messing around with the assembler code, no rebuilding modules, no ROMs, and no rebooting. Because it runs on Windows, Linux, and macOS, you can do all this on any modern system that you have access to. Or you can use the cloud-based systems as well to test your code. I use the cloud systems to test the code automatically every time I make changes. With RISC OS Pyromaniac, trying things out and ensuring you have reliable software becomes much easier. You can use the tools that you're familiar with, different editors and different source code control. Even if you want to use AI controls, you can, on whatever platform you're familiar with. It might not be the most up-to-date of systems, but it allows proper engineering practices to be applied to software development. So occasionally I get asked, what's under the hood? What version of RISC OS do we implement? And the answer is varied because it depends on what you want. The system has more capabilities and integration with the modern systems than most versions of RISC OS Classic. It implements some select features, some RISC OS 5 features, and it doesn't implement others. It really depends on what you're trying to test, what you're trying to work with. And if something doesn't work as you expect, or you want to do it differently, then, as I say, it's Python, so you can change it easily. Similarly, there's often comments about what hardware it provides. People ask about, oh, well, do we support NVMe and things like that? No, we don't support any hardware. We have no emulation of hardware whatsoever, and the only emulation we actually have is the CPU, and that's a generic CPU. The point is that hardware drivers are the domain of physical hardware, and need to be implemented for the hardware, so use the hardware. But everything above the hardware driver, you don't need that support. If you are writing a hardware driver, you know what you're working with, and you have to work with the hardware on the system itself. Generally, integrating with RISC OS is much simpler than getting the hardware to work. So there's a little trade-off there, and Pyromaniac addresses the RISC OS side of things. Like Wine, which you may have come across, RISC OS is not an emulator. I don't know if you know, but Wine is the Windows layer that you can run on Linux and Mac OS. It stands for Wine is not an emulator. RISC OS Pyromaniac is similar to that. It does include an emulator for ARM or ARC64 components, but the actual implementation of the operating system is in Python, in much the same way that the implementation of Wine is in C++. And it just translates what you're doing into the host system. Alternatively, if you want to think of it in more Acorn terms, it's closer to 6.5 host, which interfaces to the operating system through through system calls, or possibly 6.5 tube, or even like the BBC Micro's tube, which was the interface that you had to separate hardware. In the very early days, when the ARM was first being developed, the ARM was first tested on the end of a tube. It's also kind of similar to ARM's semi-hosting environment, where most of the system is running on a host system, and the actual implementation you're working on is on the ARM. So there's many ways in which it's the systems that are similar to what RISC OS Pyromaniac does, but get the idea that it's not just an emulator, it's not just an operating system, it's a separate layer. As I mentioned, RISC OS Pyromaniac only provides access to the RISC OS APIs, not hardware. So that means if you're writing code that doesn't access the hardware, you'll be able to use that code just fine on Pyromaniac, which means pretty much all software, because there's very little that actually touches hardware-specific components. And as I say, it's written in Python, so you can use other tools and other Python modules at the same time. The back end is something called Unicorn, which is a QEMU-derived system. QEMU is a well-known emulation system for many different platforms. And Unicorn provides the ARM emulation and the ARC64 emulation that the system uses. Okay, so this is a diagram of how it all fits together. So if we come over here, there we go. So it's all layered in a similar way that you would with a normal operating system. You've got the user space at the top, which is usually the things you write, written in ARM or in ARC64 or other architectures. You've got modules, which are also implemented by you, but there's also Python modules, which provide some of the more lower level interfaces. So as you can see here, I've suggested utility module, OS commands, debugger, draw, internet module, and there's a load of others. There's about 80 modules, I think, in Pyromaniac now, something like that, I don't know. And then below that, you've got all of the kernel. So some parts of the kernel have become removed over time. Other parts are separated. Each of these can be debugged independently in Pyromaniac. So whereas in RISC OS Classic, you'd have to rebuild the ROM and then turn things on, to turn switches on and off to debug it, that's all runtime configurable in RISC OS Pyromaniac. And then finally below that, there's the actual emulation layer that when you call into this ARM code at the top, this goes and handles all the emulation. And in theory, you can switch out the emulation layer for another emulation layer. That is much, much closer to being able to be done now. And then finally, there's the tool at the bottom that is the how you call it. Strictly, it's not just this, because the harness in the RISC OS build system is actually a different program and runs things in slightly different ways, but it's basically the same sort of thing. So why did I want to do this? Well, I've been working on the project for over 6 years now, which is quite seriously a long time. And I create a new release every month, and the November 2025 release is number 77. And it's a lot of time working on it. And yes, I enjoy it. But there is a point beyond just enjoying it. I always want to build things that let other people do stuff. Operating system development is clearly a big part of enabling people to do things. And initially, I wanted a way to test my changes to the compiler and the modules I was playing with. But Pyromaniac has grown, and now, well, it can run games. It can do online services. It can run the desktop. It has integration with the host system. And it's extremely good in debugging things. It has met all of my technical needs so far, pretty much. And now I'm using it for those original goals as a way of testing and experimenting with RISC OS. That's one of the things I really try and do now. And that's why my duration has changed a little. So, for anyone who hasn't seen it, I'm going to do a quick demo, just so we've all got a shared understanding of us running it. So, if I can share the right screen, desktop 1, there we go. Hello. Right, I'm going to go and run, I'm going to run Pyromaniac, that pyro.py script, and I'm going to run it with a configuration file. So this configuration file declares load me a number of modules, set up some settings, and then start the system. And so we're going to start that up. Obviously, Pyromaniac, as you know, runs slower than normal RISC OS. It's emulated, and it's running in Python, written in Python. So it takes a while. And there was the boot menu. So standard RISC OS select boot menu that would normally start up, and then we can go and start the desktop. The banner here is decompressed using Squash, which is actually implemented in Python. All of the sprite rendering, all of this is all done in Python. Well, it's all decoded in Python, and then it's passed on to Cairo to do the rendering. And as you can see, you've got a desktop, as you might expect. It's limited because I've cut it down for here. You've got a task manager, and you've got a filer. That's the pinboard in the background, obviously. Hourglass. Come on. It also runs slightly slower when I'm running Zoom, but yeah, that's life. And we can run we've got filer working, we've got applications here. So there we go. We can play Minehunt. Ooh, ooh, ooh. Usually I blow myself up on the first one. Come on, can we do this? No, I blew myself up. There we are. It works. I mean, it works well enough to run Doom. It runs well enough to run Ovation. You can obviously run Paint, Draw, and Edit. And I think you've probably seen those all before. So that's what Pyromaniac can do there. There's also, I mentioned the debug options. I'll just quickly drop to there. You can see a whole load of debug options, hopefully. You can look at any modules. You can look at the dynamic areas. So if you want to look at the modules, you pick a module. Let's pick Task Manager. There we go. There's Task Manager. And then we can go and change it into disassemble mode, and we can see the code in Task Manager. Really not that exciting as a thing, but in the sense that we can actually go and look into what's going on the system, it's really useful. We can also look at any part of the statistics about the system as well. So we can look at what filing system statistics we've got, which there aren't any.
Just a quickie, have you got breakpoints in that?
Breakpoints are possible. They have you set them as watch points or trace points. So
Yeah.
watch points on addresses or trace points on the system. Those have been there since the very beginning.
Splendid.
I would have a look at the features list, and there's a whole section on debugging on the main RISC OS Pyromaniac site,
Cool.
which talks about tracing and how that works. I mean, you wouldn't normally use it in the desktop like this. It's not that useful in most of the time. And back here, I'll just quickly say you can see that something has gone wrong. We've got a trace that's telling us that something has had there's a watch point that was hit, a read of address 0. We can see that it was whilst executing the oswise module, somewhere in the middle of substitute args 32. I've known about this one for ages, but I leave it in there because it's a useful one to say, look, when something goes wrong, you can see it. And if you see down here, it was trying to execute these instructions. And I suspect if we look at R8, we'll see that R8 is 0. There we go, R8 is 0. So that was what was happening at that point. You can get out similar information for most of the operations you do. Anyway, that is RISC OS Pyromaniac. It's a very similar demo that you saw back in, when was I here last? 2022, 2021? Many years ago. So, there we go. We've got a little bit of an idea of what Pyromaniac can do. I will also be showing a little bit more of it later on. So, let's go back to the slides. If I can find where my slide window is. That's this one here. Hey, we're back. Right, so Nemo's already asked a question. So anybody else got any questions on the general what Pyromaniac is and that area before we move on to the next section? No questions? Right. So somebody's asked me, why did you pick the name Pyromaniac? I think we have Chris Johns here. Yeah, we do. We have Chris Johns here. He's the one who's to blame for that. It's Python and it provides RISC OS, Pyro. And where do you go from there? That's the reason why it's called Pyromaniac. The subtitle is it burns whatever went before. So I had to do that as a backwards rationalization. And the second question was from Mark Stevens saying, are you using to use it to debug RISC OS or apps? Yes is the answer to that. So both to debug RISC OS and to debug applications as well. So I can debug my Pyromaniac RISC OS. I can load modules. The modules that you were seeing there, that was the RISC OS Select. There was RISC OS Select window manager. There was a couple of other modules from Select. It can also run modules from RISC OS 5 if they are doing all standard RISC OS things. If they're working with hardware, they won't work. I do not know how well this is going to work. Just since that question has been asked, let us give this a whirl. Desktop 1, please. It's been a long time since I've done this, so let's have it. I have no idea if it will work. Pyro.py config file RISC OS 5 ROM RISC OS 5 RC3. I don't know. Let's have a look at the Pyro files. This is where I've not thought about this one, so I don't know. Yeah, ROM RISC OS 5. I think that's all it needs. Pyro.py. So this has taken a ROM from RISC OS 5, 5.31 something or other. Can't type. ROM5.pyro. That one, please. Let's see where we get to. It's possible it may not even start. Lots of problems where it's accessing 0 page. Not happy with that. I have a feeling that it thinks it's got the monotonic timer at 0 page, and some module is accessing it regularly. Ooh, that's irritating. Message trans. It might be some interlock or something. Yeah, it's probably not going to work so well. Maybe we'll give up on that one. Come on, stop it, kill that. Let's just see if I've got anything in my history. Yeah, no, I don't. Right, we'll leave that one then. You can start it up, and I have done. There are videos and screenshots of it running parts of RISC OS 5. So yes, I can test parts of RISC OS. I can also test applications. As I mentioned earlier, it can run Ovation, it can run Fireworks, Pipe Dream, both of those. It runs games. It was used to develop Heretic and Hexen, and every time I go and make a change to that now, it will go and build and run the game for 10 seconds just to make sure that the game will start up and will run some frames to make sure that it hasn't become broken. And partly that's because I can, and partly it's because I kept releasing versions to Andrew that he said they don't start. And that's exactly why you have automation, to check that these things don't break. So yes, I can test. No, that's exactly the reason, Andrew. He apologised. But yes, it's exactly the reason why we have the testing. And should never be wasting time by sending things out that are broken. So that's why we do these things. Okay. Any other questions? Okay, we will move on. Let me find the slides again. Not that window, this one here. Here we go. Right. So, next thing is moving towards RISC OS 64-bit. So, let's say what has actually changed in the past few years. Oh my gosh, there's been a lot. It's been 4 or 5 years. 4 years, I think, since I presented last. And I'm not going to go through all the changes. It's all described in the changelog on the website. You can always go to pyromaniac.riscos.online, and the full changelog is listed there, which includes all of the features that have been added, things that have been changed, things that have been fixed. And there are also examples and other things on the website to show what you can do. It's a lot more featureful than it ever was before. And a lot of it is related to the 64-bit work. The last year and a bit has been 64-bit specific. But it's a large system. There's a lot that's not right. There's a lot that could be done better. And I keep finding bugs in it. That's fine. It's inevitable when you've got only one person working on something. And the reason why I want other people to try and test it as well. So, what has changed since 2022? Well, we've got a chunk of the window manager rendering has been implemented. We've got command windows, we've got error boxes, we've got windows, as you can see there. We've got a command server, which means that we can interact with the RISC OS system from the usual Unix host. Graphics support has massively improved due to games, and we have teletext as well. I'm not entirely sure whether teletext is a benefit, but I'm a completionist in some cases. And there's a lot more things as well. So the better question is, what has driven those changes? So the main thing that's driven things is that I've been asking people to try out the system, to iron out the bugs, and there's been very little interest in that. And that's meant I've had to do things myself. Fair enough. Got cheers for teletext in the pub, apparently. That's cool. I'm glad people like teletext. There are screenshots of Yellow River Kingdom on the Pyromaniac website. It works. It's not fast, but it works. The emulation is not brilliant. Anyway, yeah. I've had to do a lot of things myself, so I ported a lot of programs. I've got a lot of the software that has been written for earlier systems that other people have released. I've tried to run on it, and when it breaks, I go and fix the problems. Sometimes the problems are stupid things like, oh, you forgot to write that code, because I didn't think something was particularly important for what I was doing right then. Other times, it's something that's misdocumented, and so we can fix it. And then when I fix things, I've put in tests as well to check that things are working. The idea is that if we have the tests, and if I can get more things into the system, the more chance there is that we'll find problems with real problems with programs. And as I mentioned, Heretic and Hexen were actually developed using it. Um, it was partly a challenge to make sure that I could actually run games like that on RISC OS Pyromaniac, and partly it was to try and make sure that we can see that things are good, that are working the correct way. And I've already mentioned that we run things for 10 seconds just to make sure that it's actually working. If you go to my GitHub account, you'll see that there's quite a lot of things that exercise the system and have become useful over time. So things like the debugger tooling in Python, which I believe Mark Moxon was using to actually disassemble the Elite that he did recently, Arc Elite, which was quite cool. And there's other parts of the things I've developed that are only on my own system because they're not good enough for anybody else and they're barely useful sometimes. They've been useful for just particular tests or whatever. I've demonstrated a lot of the changes in Pyromaniac at the 64-bit presentation last year. And I'd like to say, of course, this presentation is running on RISC OS 64, but I forgot to configure it that way before I started it, so it's actually running on RISC OS 32-bit. Bother, but it does. Trust me, it does work. So let's move on to the other influences that drove the development. This is a weird one. So we're going to spin back to November 2023. I found a 6502 emulator on GitHub and I started converting it over so it used the Unicorn-like interface. Unicorn is the emulation system that's in Pyromaniac, so I thought if I could make it a little bit easier to work with and have interfaces that were similar, I could use it like Unicorn, and then maybe it could become part of Pyromaniac and we could have RISC OS Pyromaniac 6502. The original author had got it to the point where it could run BASIC as a 6502 system using the BBC ROM, and I expanded on that and hooked in some more of the system so I could trap OSWord, OSByte, and the other calls, because there's about 12 of the system calls that are provided, all the filing system and things like that. And the idea was that I would then swap that out and work it into Pyromaniac, and we'd have a slightly weird hybrid system. If I could prove that, it would really show that Pyromaniac could be used for executing anything other than ARM. But 6502 is quite alien. It could have been quite interesting to use the 6502, having the 6502 processor running your code and the rest of the operating system being implemented in Pyromaniac. But it was just too alien. I couldn't make it work. The registers have different width. There's 64K memory limit. The stack is only 256 bytes. I had thought if I could make it work, I could do anything. I could turn it into a system that was provably able to run any type of system. But I couldn't do it. It was just harder than I had the energy for. And I have a full-time job as well. So I can't do that. So as an intermediate step for x64 or ARC64, it didn't work. Hey ho, that's life. And I mentioned x64 there. I had the beginnings of an x64 demonstration application which showed a rotating cog implemented in x64 but rendered by draw. And it was kind of working, but I wasn't at all comfortable with doing anything more in it, and that was back in 2021, and I set that aside because the whole Pyromaniac system wasn't set up for that. So in December 23, because that was a long time ago, I began reworking the innards of RISC OS Pyromaniac to try and allow it to emulate something other than ARM. It wasn't going to emulate 6502, but I could try starting on ARC64. And some parts of the system were flexible enough to do that because I tried to build it to be generic wherever I could. But other parts were rather core, and it was a lot harder to make it switchable. It's still ongoing. There's some parts that are still not working properly, but it is taking a lot better shape now. That can use as a system that can use a different architecture. And one of the first bits that I started out by doing was to replace parts of the disassembler even. Blah. So previously we could only disassemble ARM code, and when you're running on a different system, you want to have a disassembly that is for the processor you're using. And already we have debugger disassemble thumb as well, and I hadn't implemented that. So I started replacing parts of the disassembler system, and that allowed disassemble thumb to work. And then because I'd done all the work on that, adding ARC64 disassembly was easy. And we gained a new SWI, disassemble ARC, which then allows you to disassemble any architecture. At the same time, I extended the debugger module. I started adding in the SWIs from Debugger Plus. I'm not sure how many people know about Debugger Plus, but if you've used Zap, you've used it. It was created by Darren Salt, and the idea was to change the way in which the disassembly comes out so that it is more friendly to you. It gives you more information about things and so on. And so it has a number of extra SWI calls, which I've now implemented. I didn't want to clash with his calls because that would then mean that it was incompatible. And so initially I skipped the calls and then, well, I implemented them. There were some calls like the replace mov r0 with not that were really simple. Others that were a lot harder, and some of which I didn't do. So we've got those implemented in there now. One of the other things that's present in the debugger module is that there are exception registers in there. So debugger also handles star show regs, breakpoint, and continuing. Now, I don't really support that style of debugger, the in-system debugger, but you definitely need to have show regs working and all of the exception dump areas. And of course, if you're moving between processors, the exception dump that you've got is going to have different registers in it. Basically, these dumps contain a list of all the registers that are present at the time of an exception and any other information that you need to restart or that could be helpful. In the old 26-bit world, it was 16 words long, one for each register. And then when we came to 32-bit, it was extended to 17 registers so that we could have the CPSR as well. In ARC64, it needs to be quite different because, firstly, registers aren't 32-bit, they're 64-bit. Secondly, there's a lot more of them. There's 32 registers plus the stack pointer and the program counter, because those are not mapped into the main register set. And of course they have different names as well. The way I approach problems is I don't like to have fixed the immediate problem that's in front of me. If you fix just the issue in front of you, you only address a single instance of a problem. I like to try and address a class of problem instead. So that means that instead of dealing with just what's in front of me, I need to think of what other cases might be needed in the future, how you might expand things, how other people might need things, and allow people to do things that you've never thought of. And thinking about problems like that means that you could over-engineer some things, and I've done that a number of times. But as an operating system architect, I think it's vital to provide that kind of functionality so that people can use things in ways you've never considered. So, in general, that should result in you having a more useful system at the end of the day. So when it came to the exception dump area, I had to make it more future-proof for other architectures so that when we go, oh, this is how it's going to be laid out for ARC64, we can also go, Yeah, and if I want to lay it out for RISC-V, or if I want to lay it out for x64, or some other system, maybe you want to run it on MIPS, I don't know, you can do that. And so there's a new SWI called OS Platform Features 64, which describes the exception dump. And this describes the layout, describes all the registers in terms of their name, where they're stored in the dump, how wide they are, how aligned they are, and if they've got flags, it also tells you about what the flags are within it. It's only one small part of the system, but it allows us to move forwards without having to worry about this in the future. So we'll move on a little bit, and in Christmas 2023, IconBar ran a series of Advent calendar screenshots. And RISC OS Open had submitted a screenshot to show ARC64 being disassembled by DecAoff. I'm relatively sure this was a fake, because it would be really pointless to go and extend the Norcroft toolchain to support ARC64, and definitely not to make it work with AOF. It just doesn't make sense when there are so many other compilers and assemblers out there that have had serious work done on them. But by that time, I also had a system that could start running programs and could easily disassemble ARC64 to the same level as that. And that felt pretty good. Updating the operating system to function with an architecture isn't easy, so it also took a long time to get everything right myself. I don't know if anybody had noticed at the time, so I noticed this when it first came out, but this instruction is wrong. And it's not the disassembly, it's actually the instruction itself that's wrong. And if you try and execute that, it won't work. It'll crash. But that's what happens when you're developing stuff. You get stuff wrong. If it was fake, then somebody wrote the wrong thing down, because it looks very similar to that one. Anyway. It was quite slow progress, but in June 2024, I finally got the first programs running on ARC64. There was a small C program that drew a cog using the draw module. You remember that one that I talked about for x64? It was that, but repurposed for ARC64. The goal was that everything that's implemented be written in C or some other high-level language. Doesn't have to be C, but could be anything else. And so to get this working, I'd been using GCC compiler to compile the programs. There's a little bit of hackery and some very dumb linker scripts, but it was running an executable file. And then a little while later, in July, I got the first game running. The first game was Chucky Egg. This is Michael Foot's conversion of the game to C. It was relatively easy to make work on Pyromaniac. And it really amuses me that the very first game that ran on RISC OS 64 was actually a BBC Micro game. I think that's quite fun. Not quite what you'd expect from a powerful system, but it's a good game. So then it came around to doing the presentations. I started creating a new repository, which was originally called RISC OS 64 Simple Applications, and it's now called RISC OS 64 CLib. And that's in GitHub, which shows off how these things work and describes the interfaces on the system. You'll find also the example cog program there. And I started expanding that further so it could actually be a full C library, and you could use it to build full 64-bit RISC OS applications. Having got the C compiler working, it was easy to get the presentation tool working, and it was important to my plans, as you guys will know. I like to have a strong need to demonstrate something that is a surprise. Getting to the end of the presentation and saying, yes, the whole thing was running on RISC OS 64 was something that I needed to do. It just was really, really important to me. And it was so painful to do. Getting the image file rendering working. I hadn't actually added ARC64 to CMunge, the module header at the time, so I had to handwrite the entire module header. But it all came together in time, and you got to see the presentation. And I had hoped that the presentation would spur people to talk about RISC-OS, about 64-bit and what could be done. And it did generate some discussion. But most of the responses boiled down to either, I'll believe it when it happens, or let's see what RUGOL do, or there's no point if you're going to not support 32-bit applications. All of which was rather depressing, to be honest. I can understand people being jaded, but after years of nothing happening for 64-bit, I kind of expected people to be a bit more excited and positive about it, but that was life. I thought that seeing something that was being done and that we were actually able to run programs was, I thought, something people would be excited by. And they were in the meeting, but nothing really came out afterwards. So the 64-bit presentation also had links to all the resources, so that I thought people would be able to build on that and try and take things away. I linked to all the built examples, the programs, the port of Richard Russell's BBC Basic, the C library, and the decisions and technical proposals that I had. And I always try to do this for my presentations. I always try to ensure that we've got sufficient information so that people can look at it and come back and say, oh, that's good. Or more specifically, they can't come back to me and say, you didn't do enough. That's what I really get worried about. And this presentation is no exception. So I'm going to very quickly show that we've got some resources here. If I can do that, if we bounce over to there. Hello everybody. Yeah, there we are. We're now sharing this screen. I'm going to go and show you this one. So if we go to my presentations, this is the presentation website. And if I reload it now, come on, reload it. We've now got the presentation here for this presentation. All the slides are here. The video will be here if we make that work. You've got links to all of the bits on there, and then links to all of the resources and things that came off this.
We're still seeing the other slides.
Oh dear, I failed to share the screen. I'm useless. Let's jump back. Yep, you have to click the share button.
That's it. Can see it now.
We're good. Thank you very much, Brian. We'll just edit that bit out. So as you can see here, no break in this at all. The RISC OS Pyromaniac evolution is here, and you can see we've got the slides on here. You can pick through your slides, see which ones you want to see. All the links to all the details, including my notes that I'm reading from, and links to all the pages and things that I will reference in the video. So you can see all of these things. You can see random videos that I put together and the like. So all of these resources have been built so that people can use these. There's also all the things that I've got on GitHub. So there's RISC OS 64 status pages, my current projects for WIMP templates, and all of my repositories that have got, many different RISC OS projects in them, which you can all have a look at. They're all shared. People want to contribute to it, it's great. And on the RISC OS Pyromaniac site itself, there are lots of other examples and images as well. So if I go there, that one there, please. Nope, that's not it. I pressed down too far. You know what's happened? I got really flustered because I made a mistake. On here you've got examples. All of the examples from 2023 are here, including things like the Yellow River Kingdom teletext example and RISC OS 5 desktop and things. So there are a whole bunch of things. But I try to put these things out there so that there is sufficient documentation of what's been done and what is possible, so people can get involved. However, there is only so much I can do because I've got a full-time job, I've got a family, and I just want to communicate what's there because that's the key to the success of open source projects. Right. Small digression. We'll return back to the slides. Here we go. There we go. That was the presentation resources. Yeah. So next, I'll talk about creating the build environment. So in order to build all of these things, I had created a Docker image that I was using for working with RISC OS builds, as this makes for a really good distribution mechanism and way of developing things. For people that don't know Docker, so Docker is kind of like a mini Linux small distribution that you can just load up and use momentarily for things. It's also used for most web services these days. Almost everything you ever see these days will be running with Docker somewhere in the background of it. So it runs on macOS, Windows and Linux, and it allows you to run applications in a small containerized form. And so the Docker image that I got had got most of the 32-bit tools, and I started creating a variant that included 64-bit tools, building in GCC and all of the other things you needed to build 64-bit code, using what I'd learned by building the C library, building Jucky Egg, building BASIC, building the COG demo. And I've offered these around to people, see if I can get any requests from people to test out the system, but nobody's biting. The build environment has continued and is now really more featureful than ever. We'll see a demo of it later on as well. So, in parallel with this, I started doing some live coding. And I'm sure people have probably seen me every week posting up, I'm doing live coding. We've had a few people from here turn up there. It's been really nice to see you. But the idea of this is that I share my screen for a few hours every week whilst I'm working on a RISC OS project. The first one was to build a debugger module in proper ARM code, rather than being the one that was in RISC OS Pyromaniac. And I used a lot of the knowledge that I gained from working with RISC OS Pyromaniac in that. Why did I do this? Partly it's because I enjoyed watching Matt Godbolt do some live coding on his compiler explorer. It was really fascinating to see an expert working through things, explaining what they were doing and interacting with people, asking questions and getting back feedback from people that were watching. I thought that was really, really wonderful. And I've never felt great about my presentational skills, so I wanted to improve that. So I thought this would be a useful way of doing it. And I wanted to show people how to do stuff, and that I could do things live was quite nice. Someone at a meeting, I have a feeling it was John Rickman, said to me, some people learn better by watching videos. I have a feeling it was him. If it wasn't, I apologise, but he'd suggested that, and I'd gone, no, I don't want to do that. And the idea had sort of come to the front, and I'd gone, yeah. Was it you, John?
I do watch an awful lot of videos. They're mostly on golf these days, but yes, it was.
Yeah, it just seemed like something that was. It came back to my head, and I was like, yes, this is important, because not everybody watches things as like little small things. They sometimes want to watch videos. They want to read things. Some people want to learn by doing. So this is a different way of doing things. Paolo had been doing his community videos, which were a lot of fun to produce. So expanding this was quite fun. And I hope that people would be encouraged to try and join in and just do things. I also want to make a quick shout out to Dave Thomas for his suggestions. And he's also did the titles on the live coding series. So thank you very much for that, Dave. So these sessions have now produced the debugger module and the system variables module, and I'm working on implementing window templates, which is going okay. I hope it's interesting to people. It will be continuing. So it was quite a long project, but it worked out quite well. I've now got a version that runs well enough that you can use it in Zap. I hope you can see it there, but that is actually using the module that I created inside Zap to disassemble something. It's actually disassembling the debugger itself, I think. But yeah, it was a lot of fun to do that. If you go into the session itself, you'll actually be able to find it. There's actually a section where we go through it and we have a look at what's working and what isn't. You probably can't see it in this quite so easily, but Zap hasn't coloured that BC properly or that FC, and that's because I'm outputting things in lowercase and it's expecting them in uppercase. So it also found bugs like that. It's like, oh yeah, I didn't notice that, which is quite cool. And whilst doing this, I was also implementing the ARC64 disassembly and the thumb disassembly in there. And in particular, the thumb disassembly, it highlighted a bug in the RISC OS Select debugger, which was showing that it wasn't actually doing the right thing when it got certain instruction sequences. And that bug is still in RISC OS 5. So I've put up a patch on the RUGOL forums which addresses that if they want to use it. So it is useful. And this is one of the advantages of having multiple implementations. So we move on now, and this is Christmas 2024. Iconbar again ran their Advent calendar screenshot series again. And this time I submitted quite a few examples. Some Christmassy snowman that ran on RISC OS 64, a compilation disassembly of this rule code that they did the previous year, and an example of RISC OS Online Shell switching to 64-bit, and a port of the original adventure game, Adventure. And you can see on here, this is the 64-bit Online Shell disassembling some ARC64 code. I'm looking forward to the Advent calendar this year. I'm going to have to find something exciting to put in because I haven't got much left. I think this presentation is going to do most of the exciting things. Oh well, but we'll see anyway. So yes, that was a lot of fun. And then in early 2025, RISC OS Open announced their moonshots. They were setting up a different class of bounty towards making components of RISC OS able to be ported to RISC OS 64. At the time, I was quite hopeful that this would mean that RISC OS Open would begin to work with the community and encourage development and discuss their plans and coordinate some work to actually advance the operating system on a modern system. And I was hopeful that, having discussed the issue and presented possible solutions already in my presentation and demonstrated functioning versions of RISC OS running 64-bit code, that they might want to discuss some of what could be done. So when nothing came of that, I decided to push the issue by making a claim. Paolo. Not repeating that on here. I'll try again. When nothing came of that, I decided to push the issue by making a claim for a small portion of the work that I'd already done. As I'd been largely producing a system that directly addressed the issues of experimenting and moving RISC OS around, it seemed kind of pertinent. And if they weren't interested in coming to me, given my background, I would take what I've got to them. So I spent quite a while putting together a document describing the claim, what had been produced, how it fits the goals of the moonshots, what facilities it provided, and the value on it. All backed up with documents, videos, articles, presentations, open source stuff, those sorts of things, to show how it fits together. And we had a meeting to discuss this, and I answered their questions about the claim. And they stated explicitly that bounties would not be paid out for things that had already been done. But they were interested in exploring possibilities, and despite seemingly not having understood how it was useful, they left with a better understanding of it. And I, for my part, offered the system, the build environment, and other tools to them. It did seem quite positive, and I continued my work towards 64-bit and creating C versions of modules, updating Pyromaniac 64-bit, and doing the live coding, as I've mentioned, so that I could start moving more into RISC OS 64. A slight aside here, the term RISC OS 64 is purely one of my own making and is purely to try and make a distinction between the 32-bit system and 64-bit systems, because repeatedly saying RISC OS on 64-bit or something like that is tedious. So that's the only reason. It's not actually a brand name, product name, or anything like that. It's just RISC OS 64 means RISC OS running 64-bit code. Specifically ARC64 code, sorry. So at the same time, I made sure I was communicating what I was doing to the community through the forums and publishing to GitHub. So you'll have seen my status updates that I keep posting up to say this is where I'm up to. This is one of the things I want to keep doing, is trying communicating where I'm at and what is going on. And I think ROUGOL forums are the place where the RISC OS users will be finding out what's being developed. Specifically, the 64-bit forum is perfect for communicating 64-bit work. Yay! But nothing was forthcoming from RISC OS Open about progressing RISC OS, or in producing any plan for how to get there, which is kind of what Paolo said. So, next section is to talk about how I'm changing my approach. Does anybody wish to have any questions before we move on to the next section? Because I have spoken quite a bit there. Any questions, anyone? Go on.
Keep going, Jeff. Don't be discouraged. Just keep going. You're doing all right.
Thank you very much. I do intend to. I'm trying not to be discouraged. Right, just give me a second for a drink. Oh, yes. So, if we don't,
I think the questions will come once we understand the section of the changing my approach, because that builds on top of what you've just been talking about, presumably.
It does, yes. But
certainly that's why I wasn't asking any questions, because a slide like that says, let's hear the change of approach.
I knew I should have left it off the screen before I asked the question, shouldn't I?
We're on the edge of our seats.
Right, okay. So let's move on. So the thing is, if things aren't working, you try a different way. So I've got a question. Oh, did you talk to RISC OS Open about the RISC OS 64 ABI changes and the module header changes that you've implemented? That was a very good question from Nitrax there. So I had previously communicated the changes that I've done for the module header and for change environment and for some of the other parts of it. Because those areas are not registration areas, I've been told explicitly to go and we don't have registrations about that, so go and put it into the wiki. So I put it into the wiki. I have also mentioned explicitly on the 64-bit forum, the forum that Steve Revel created explicitly for the purpose of discussing 64-bit, those issues. I've also mentioned some of these changes in the past on the general discussions. And of course I did a whole presentation on it. So I feel that RISC OS Open have certainly had enough opportunity. Also, you must remember that as part of the claim, I included all of the documentation about these things as part of the claim to say, look, I've done this technical work. So I felt I have communicated to them these things. We had a short exchange on the forums a week or two back about the how to communicate these things. It feels to me that I have communicated those things and I've had no other feedback from them, so fair enough. So hence why my change of approach. So that was a very good question, thank you. I can potentially go into some of that a little bit more detail later on if people have follow-ons from that, I suspect. So what's going wrong? I'd made very little progress on involving people, and specifically with ROUGOL, as well. And because ROUGOL were not being involved, I decided to change my approach. They weren't interested in what I had to offer, and they weren't seemingly going to offer any guidance on what they wanted to happen. I've been waiting for them to do this. So my answer was to try and think about things differently. And nobody else is really working towards 64-bit. There are people like Paolo, there are people like Simon, who are doing things towards this, but nobody's quite taking it the same way that I am. For reasons, everybody has their different approach, and that's fine. But I wanted to start looking at why my things were not making an impact. So I decided to look at what was missing and why I believe the community wasn't engaged. And here's my sort of conclusions. There's a degree of apathy. There's a lack of focus. Some people are just waiting for things to happen. There's skepticism that anything will happen. There's those that feel resigned that it's a lost cause. There are those that don't see a need to change. There are those who just want to use the system. And there are those that just wish that things were the way they were 30 years ago. And there's a lack of time and inclination because people have full-time jobs and families and they don't want to spend their time on that. All of these things, if you mix and match them, I think give you a good definition of what the RISC OS community's view is. And I will be clear that some of this is also how I feel about things. I do understand, I do agree with some of them, maybe not the feeling it's a lost cause and the like, but that Andrew has also said a lack of skill to usefully contribute. That is completely true as well. I agree with that one as well. And that is also a thing that we need to nurture. If people want to be able to learn, then to try and do that. And that's kind of why I'm going with some of the live coding. Maybe I should do something a bit simpler to try and get people more involved that side. But again, not just go ahead, Paolo. I was just about to say there's people like Paolo who have done their introductions to things and their videos. Go ahead, Paolo.
Yeah, so I just want to interrupt to say, Andrew, I agree, but we need to remember that this is the reason why we should have a talk, because there are plenty of tasks when writing an operating system that many people can contribute without having actually the skills to write a kernel. This lack of communication is the biggest problem. So I'm loving this presentation from Charles, beside of all the interesting update, because it's finally throwing these questions or points on a screen in front of everybody. We need to talk, guys. We need to openly talk. That's all.
I think talking about the problems and talking about what we can do to address them is useful. And again, I don't want to be critical of anybody in the community for anything. There's a degree of apathy. Yeah, there is. But also, that's something you have to try and overcome. What I was trying to say was we can't change people. But what we can do is affect their perception of things. We can try and encourage them. We can build things that people can use. And you need to make sure that people know about things. As Paolo's just said, you need to be able to communicate stuff. And you need to engage with people when they are involved. And you'll see that that's part of what I try to do in the live coding as well. Engage with people and try and talk to them about what's going on. And you need to make sure that they have the ability to be able to do things, which is kind of the sort of thing that Andrew was saying. I don't have the ability to teach them how to do some things, but there are ways in which that can be approached. I think I'm about to repeat myself.
Okay.
Sorry, go on, John.
Well, it's not apathy. It's a sense of hopelessness rather than apathy.
Yeah, I think the resignation of the I think that's a big thing, and it shouldn't be there, because much as I've just said, RUGOL haven't done much for me. They have done a lot for the community. They have brought things forward. They have managed to produce things, and not just RUGOL, but the other software companies and open source contributors. There are people doing that. Maybe that isn't enough. Maybe there needs to be some more work done to try and encourage that. I don't have an answer, but long ago, I think it was Andrew was saying it would be really good to get a little developer meet together to try and just talk about some of the things we want to do and try and get an idea of who can work together. I'd love to be able to do that sort of thing. You can't really do it at shows because you actually have to talk to like customers and stuff. But those sorts of things could be something that could be done. I'm not going to make the suggestions on that side right now. But yeah. Excuse me. So move on from what was going wrong. What have I been doing to try and deal with this? Well, I've been trying to communicate what I've been doing with regular announcements of things, website updates, details of how to use tools, making software available, and trying to open source whatever tools I can so other people can use them if they want to. Placing them on GitHub seems to be the best way to do that, and making sure they're available and people can get involved if they want. Peter's just mentioned that its sticking point is how to move forward. That is quite correct. Some people may not want to work the same way, but yeah, that's a very true thing. But the other side to not having a different idea is that, yeah, that doesn't mean the fact that I want to do something one way and somebody else wants to do something a different way and whatever doesn't mean that any of those are wrong, and potentially all of them going to happen at once and you get somewhere. Cross-pollinate, think about things different ways. Anyway. I've also been trying to demonstrate things myself, providing videos, screenshots, descriptions of software and plans so that people can see what it means. Not everyone takes in things in the same way, as I've mentioned about the videos, and so different media can help. And that's also partly stemming from Paolo and the group that is doing the developer meetings, wanting to try and communicate and help people with things. That side of things has influenced my thinking, and saying what I need to do there. And I do presentations, I do live coding, and I hope that I can demonstrate to people how to do things. I also hope that I can demonstrate the way in which things go wrong, so that when they do go wrong, show that you can get out of it and you can laugh about those things, and that we get very used to seeing finished products appear, and we forget the large number of mistakes and stupid things that go on between them. If you've seen any of my live coding, you've seen a lot of the issues with moving things forwards there. Just hang on a second. I was seeing. Right, so Andrew has said quite a pertinent one here. Another aspect is the fear that something will be rejected or not accepted as a way forward by, for example, rule, and thus time is wasted. At the very least, I'd be happy to project manage 64-bit work, but does not want a repeat of the TCP/IP stack. Absolutely. Time that's wasted is silly. It's just pointless. And the fact that we are now in that situation, I mean, yes, having two stacks means that you've got two competition, you've got two things that can be tried out by people. That's great. But now you split things. You've also split development. Waste of time. Anyway, that's had enough discussion over the years, I think. Phil has just said he was staggered to submit code and get the response, "We don't offer a code review service." That is a frustration. It is very, very difficult, and particularly when there are intelligent and qualified people to be able to do that. Maybe that's something that we just have to take on as a community to see how to do things. Chris has said that wasted development time is the scarcest resource. So, yeah. So, as I was trying to say, sorry, we're going back through this. I'm also trying to provide encouragement, and that's one of the things that I'm just trying to give people encouragement to move forwards and to show that development isn't stagnant. So I think I've been able to address some of the areas. Maybe I don't solve those areas, but I've tried to address some of the ones, and I've tried to reach people, but it isn't. Sometimes even if people can see what you're selling, they're just still not going to be interested. So that's fine. But there are areas in which I can improve. Live coding is intended to improve my skills in presenting live and to encourage people to move forwards. And I can do things better. I've been trying to engage with people in that to say, can you supply me fixes? Can you offer me suggestions? Dave in particular is wonderful about pointing out my mistakes when I'm in that and suggesting things to me. Other people can get involved with that. That's fine. If people are skeptical, ask questions, see what's going on. We can try and do something about this. But what I've tried to do beyond this, my approach change has been to go, all right, people aren't seeing a clear plan. They aren't seeing the progress coming across so clearly. So I've started out doing a plan and started providing much more regular updates in the hope that this addresses some of the issues. Maybe not everything, but this is my things. So, here we are. I've just skipped a page. Sorry about that. So, when I created RISC OS Pyromaniac, it was easy because I knew what I needed to do. But the work towards RISC OS 64 is different. I can't do it on my own. And I don't see any need to, because there should be other people who can help, please. But I do have a reasonable idea of what's needed and how it might fit together. That's what I think, anyway. And having a plan can help you work out how difficult a project is. It can iron out the problems before you hit them. It can tell you how long it's going to take, maybe. It can also help others to see how to do things if they don't know. And it can allow you to do things at the right time, not putting the cart before the horse, as the saying goes. And it can give you confidence that things are moving and there's progress and how far you've come. Creating a plan would, I think, meet or at least contribute to some parts of the things I saw as problems. And a plan would allow me to see that I was achieving something. So I started working out a skeleton of a plan. And what I produced isn't a project plan. Andrew has said he would be happy to project manage something. May hold you to that, Andrew. But
I know I'm letting myself in for something horrible, but
No.
do hold me to it. I want to support you.
that's fine.
And Paolo, for that matter.
Yes, there are lots of different areas that can be worked on here. Any cats that can also be involved, I'm very happy for that as well, Eric. Sorry, distracted by cats. So I started working out a plan, and it's not a proper project plan. I don't set out everything. I've not broken everything down to see what's going to be involved. If I were to try and do a full plan, I think this is where ROUGOL have also got a sticking point. I'd have one of the best managed RISC OS projects by about 2030 and nothing done. So instead, I've tried to work out how things might be developed and what phases they might fall into, with details being worked out maybe a little later. The goal of producing a plan, not the goal of the plan itself, but the goal of producing one, which is a little bit meta, but hear me out, is to show that there is a plan to people and that there is some focus, to show that there's progress and that people can be encouraged to move on. Breaking down the recognisable milestones and giving something to look forward to. Providing some encouragement to people, explaining how we can progress and giving guidance for anyone who wants to be involved. And limiting the depth so that we don't get overwhelmed by the scale of this, because changing a whole operating system is massive. And I'm sure Acorn had the same thing when they went and decided, oh yes, we're going to ditch 6.502, create our own chip, hardware chip, and an operating system to run on it. That's a daunting task, but it is something that's achievable. So I think so far my status wiki has started doing parts of that. I've broken it down to phases. Each phase has something of a focus and goals and tries to show progress in other areas. And I've tried to define the terms so I can talk consistently about the development process. For some areas, we've got more information about what's involved. In other areas, we just had to leave it less defined. So let's work out what we mean. I've said I've defined some terms, so let's try and give them some meaning. During the development of components and features, it's important to see how you're progressing, and not every component or feature will go the same way. There's a lot of assembler modules, and those will basically need a complete rewrite, and you'll need to design them from scratch. Other times there are libraries and prototype modules where you only need to get as far as a small section of it, and then somebody else can take over. And things like filing systems are a good example of that. You don't need to provide a full filing system. If you provide a skeleton for how a filing system works, filing system in C with a bit more on it, then other people can fill in the gaps. They can do the complicated bit of actually building the filing system and not be bogged down by the fiddly bit of wiring it up to RISC OS. Those can make things easier. And similarly, you've got things like the original C components, like Toolbox, like Mind Map, like color picker, things like that, filer action, which probably will work just fine, but they'll need changing in certain ways because of different word widths and register widths. I pressed the wrong button. So this is the diagram that I put together to try and describe the process that you go through for almost all the components. You start out by investigating them, and then depending on the type of module you've got, you either create a stub and you build it, or it's a prototype because it's a hardware dependent module, or what's the thing called? Filing system, or something else that you're going to provide lots of different implementations of. Or you just provide some internal components like interfaces to creating objects, deleting things, doing general housekeeping. And then you start making it functional in all cases. Finally, you get a complete module which you test, and you get tests automated. Now, a proper life cycle actually has cycles in this where you go round in circles or you do your tests at the same time. But these are steps that we can actually go, I've reached this stage, I've reached this stage, I've reached this stage, it's now functional. I'm defining functional to mean you can start using it in real terms. It may not be doing everything, but you can start using it and testing it, and people can start thinking about what's wrong with it. And you can start giving a progress chart to say you've reached these stages. Obviously, it's not the complete story, but it gives a way of trying to measure progress. So that's the idea anyway. And I'm initially focusing on ROM modules because that's the easiest thing to start with. So what we're now going to do is I'm going to go and talk you through the plans that I've had, which people might have looked at, but here we go. So let's go and share things. We press the share button, we give it the window, and then we press share so that people can see it. There we go. I'm a competent person who can work computers. Right, yes, we can see it. Good, thank you. Right, so we're going to have a quick look at the status pages. So let me find the status pages. They are here. GitHub RISC OS 64 status wiki. This is the top page. The main index has got links to all of the sections, the terminology I just talked about, and how to define things, just that we're talking on the same terms. And then what work we've got planned in each of the phases. I'm going to give an overview of each of them, but basically that's the structure of things. And I've tried to include percentages that say how much through this we've got. This is all automatically generated, so you can actually see more information about what is going on. So let's have a look at what is in phase 1. So phase 1 here, we're 63% through it according to my things. It's intended to show people that the work has started to happen. It's not just a PR exercise. It is intended to show that we are actually developing things, but we're trying to encourage people to get involved, to show, look, this is something, it is working. There are things that are moving. And each of the phases has a summary and then what we target here. So the idea is that not everything will reach complete functionality. Some things will move a little way along, and some things will just be stubbed. Other things will get as far as being functional. And the idea is that by moving things along in little chunks, you can have them starting to be useful, and you can start showing people that there's progress happening. You remember that I mentioned the question that was asked about version that was implemented. Well, I'm choosing the style of modules that I did in RISC OS Select. Why am I doing that? Because I've already worked out the split out of the kernel of how you extract these things for things that are entirely independent. And because I've already worked that out, I'm not going to go and undo that or try and work it out again. So that's why, for example, conversions, evaluate expression, CLI have all been split out of the kernel. They're not in the kernel in this case. However, they could also be reintegrated into the kernel because it's just C code. That's all I'm doing. So we've got some kernel components here. We've got things like system variables mentioned here somewhere. System variables, there we go. It's a kernel component, but that's been split out. And then at the bottom, after we've described all of this, there's a nice graphical chart that shows how far we've got through. And this is what I mean about breaking these milestones out. You can actually see that boot commands, for example, is pretty much working to the level I expected it to. Buffer manager, I've only got as far as a stub at the moment. Debugger, well, you've seen debugger, it's quite complete. Other bits, OS commands only a little way, so on. So that's why I can now measure it as being 65%, because any of these incomplete sections are the part that hasn't yet been done, the 35%. And as we progress, I keep updating this and putting new ticks in. So as you can see, there's quite a few components in just this phase. But you might be asking, why don't we have something like file switch in there? Isn't it key to having a working system to have file switch up there early? And the answer is pretty simple. We don't need file switch. We've already got a file switch that's working in RISC OS 32-bit, and we've got RISC OS Pyromaniac that already implements a file switch equivalent interface anyway. So we can build something that works on top of that and prove that it works, and then we can build file switch and prove that it works because we can prove all the file systems work with it. So we can test those independently. File switch doesn't have to come early on. You can start building things, and that's kind of how, for example, Steve Revels decided to do BBC Basic. Like, ignore everything else that BBC Basic relies on, VDU system, all the rest of that, sound and all the other bits. Just work on that component, which you can do. So that's why I've split things up in some of these ways. And it's entirely possible that some of this will be wrong. It's been quite an arbitrary split, and some people need to think about what's going on and discuss, is that right? Should we move these things around? Is this phase too large? Is it too small? Have we got more people to do things? I don't know. So that's why that's there. One of the advantages of having Pyromaniac is we can test out the components even when we don't have the whole system present. So we can. It's kind of like when Acorn had the ARM board running on the tube, because they only had parts of the system working, and they could just keep trying out different things. And as you can see, I haven't said that anything is complete in this phase. Doesn't matter. I just want things to be functional, good enough to start to be useful. I kind of define functional as being just a little bit more than minimum viable product, something that you can start working with. So, sorry, excuse me. Some of the components, like you see here, the window manager, I've actually split up into separate sub-components. And the reason for that is because window manager is massive. It's got lots of different bits, but they're actually quite separate, and they do interact, but you can split them up. And the same will be true of things like file switch, file core. Some of those bits can be split up because you can handle, for example, path parsing in a different way and things like that. So I've started to break some of these things up. So if I go and click on one of these now, I can look at the WIMP templates, for example. Here we go. And this tells us what we want to be able to do in this. So here's where we are. Current status is we've got to a stub. In phase 1, I'd like to get all the internals working, but it isn't until phase 4 that I want it to be functional. And I haven't defined when I want it to be complete, because I just haven't. So the idea is that this is intended to implement just template loading. And here we've got a description of what functionality it needs to provide, and the SWI calls it needs to use, and then breakdown of other things. There isn't anything else in this. And what we can do is we can tick them off when they're done, and that gives us another indication of how successful and how far we're getting through it. Again, giving communication of what's going on and how things are going, and whether they need to be done at all, even for some cases. I've tried to break down all of the modules in the ROM in this way. I probably missed some. I know I've not done everything. And I wrote a program that actually programmatically extracts a lot of this information from the modules that already exist. The other bits need expanding on via human, which I haven't yet done. Eventually, I will fill in more details on these. So that's what I've been trying to do as part of the plan. It isn't well structured. It isn't complete. But it is trying to put together something in a mostly structured way so that people can see what's going on and that I know what I'm doing. And if anybody else wants to get involved, they can see what they're expected to do. So if I want to have a quick look at the most advanced one, if I just find the most advanced one, progress converting, I think it's this one. No, it's not that one. It's in the current status. There we go. So we look in here. This is actually the full status of everything. If I have a look for basic, here we go. Basic here, we've got expected to be functional in by phase 2, and that's based on my feel for how far Steve's been getting on. And this is the list of all the functionality that BBC Basic has to have. There's a huge amount of stuff, because BASIC is massive and complicated. And it really matters that you can actually see all of the things that are involved. Nobody should be thinking this is a small task. And Chris has just said the impact of making progress shouldn't be underestimated. It really does help to be able to see that you've got some chunks done. Yeah. So these are all the things that you need to do in BASIC to get things working. And this isn't just my information. I produced an original list, and I've spoken to Steve about this, and he's given me a sort of list of the things that he has managed to achieve out of it. But he's not ready to produce a status update yet. But he's actually broken this down much more granularly than I had. So that's why this is a big, long list. There is a lot to be done, but you can see it, and you can start thinking about how you break the problem down. So, excuse me a second. If I just go back to the slides for a moment. I'm not going to go through all the components and the phases, but just say that further in the future, the less firm the plans become and the less detail is present. Some things might be need moving, and there will be a lot of refining that needs to happen. There's a hope that I have that the later phases will have more people working on it than just me, and so we can get more done. But you got to hope on these things. I'm hoping that encouraging people will get some people interested in being involved and doing things. And if they don't want to work on phase 1, they can work on phase 2 or phase 3. Doesn't really matter. Try and mix and match what people's skills are, even if it ends up being people documenting things, or, as somebody just suggested, designing icons, or working out ways of actually interacting with things. There are lots of things that could be done. But I'd like to get people involved in trying to take things forwards. as I've been developing the components, either on my own or as part of live coding, I've tried to include tests because I want to be able to show that 64-bit components are working and avoid issues coming up later. As we know, RISC OS Classic isn't actually tested all that much. It has manual testing, but not automated testing. And so I've been trying to build that into the things that I've been doing. And in the repository, there is a directory that contains all of the modules that are present. Hang on. Thank you. So we've got a list of many modules that I put in there that are currently built. This is the 64-bit versions of modules. There's, I can't remember how many, there's quite a few. Not massive numbers, but there's quite a few. And we can see in here what the components are. And we then need to test them. So what I do is I go and throw them at the build service, which then goes and loads the module and then kills it. Most rudimentary of tests you can possibly do, but it at least proves that it hasn't broken. And that gives us a degree of confidence. And in each of the repositories, there's even more testing going on. But these things are being tested. So you can see here, I've got examples of absolutes. So this is stuff from the library. And these are modules that have also been tested. I agree. A lot of the audience are users and tinkerers, so they may not see the value in that, as you say. The point of the testing, I'll try and expand on that a little bit, is a lot of the time when you're trying to develop things, it's very easy to go and make a change somewhere and then break something that somebody else was relying on, whether that be something that they didn't need to rely on and they shouldn't have been relying on, or something that was you actually didn't intend to break. And if you've got some tests that happen all the time, regularly and consistently, and they're written in not manual, I've clicked on these things or whatever, then they've always done the same way. So you can always check that things have not been broken. And there's an important distinction here. So when I say something's been broken, that doesn't mean it was wrong. So it's possible that your test was wrong. It's possible that your assumption was wrong. And it's possible that it's just fine to break it because it was already so bad that you had to do something about it. So just knowing that something has changed is important. There's another side effect to that, which is that if you've had to change the tests, that may be something that can go into the change log to say, this behavior has now changed, and you've now got a record of it because you had to change the tests. So there's a lot of things that go into this. If you have testing for the whole system, you don't have things falling back to old bugs. Oh gosh. I think Select 2 to Select 3, the first issue of Select 3 had a couple of bugs in it that had regressed from Select 2. We'd fixed them, and then they went and got broken in Select 3. And that was because I didn't have some tests and I'd forgotten and reverted something without realizing. And I was an idiot. But it teaches the value of putting these tests in. So that's the reason. Paolo had just mentioned that it was really important to be able to do that. Not everybody will want to be able to do that, but it is valuable. The other thing is that each of these individual components should be, because RISC OS is modular, testable independently. They don't need everything else to go alongside them. So you don't need a full ROM to be able to make sure that things work. You can just try out this one thing. And I believe that should be something we encourage. Already the internet stack does this. It gives you a whole bunch of things that are not a full ROM that you can put on your system. And that could be done more often. Anyway, that's the testing we do on that repository. Oh gosh. How do we test things without an OS to run them on? Well, that's easy. We've got two operating systems. We've got RISC OS Classic and we've got RISC OS Pyromaniac. And we've also got any other environments. If Paolo gets his Merlin layer for RISC OS working, we'll have another version. We'll be able to try these things out, and one of them will almost certainly be right and others will be wrong, or vice versa. having more reasons to do things means that you can always go and see how things are different, or accept that. That's also fine. And there is the build service to be able to run things on if you want to test things automatically. I've said that we can build RISC OS components, but I haven't discussed how you build them. Obviously, we've got Norcroft, which can build 32-bit code, but there isn't a version that builds 64-bit code. And that's fine because other far better solutions exist. It would be quite insane to update Norcroft to build 64-bit code when we can use GCC, Clang, TinyCC, commercial products, all of which have had so much more development and testing and experience go into them. If Norcroft gets updated to be 64-bit, that's wonderful. But if it doesn't, then that would be a problem. That wouldn't be a problem, rather. Hang on a second. Hang on a second. Get myself a drink. So that I don't see that not having Norcroft is a problem. And the reason I don't see it's a problem is because I have been using GCC for all of my builds. Wrangling GCC to work in a way that RISC OS likes isn't that hard, but doing it with 64-bit was a bit more tricky. Together with the new C library, we can use RISC OS 64, and it's taken a few months. I've built some good tooling. I've been looking for someone to test this, like many other things, but I haven't had many takers. The build environment I've got uses Docker, as I've mentioned, and lets me build software in a simple way. And I've set it up so that you can build 64-bit or 32-bit code in the same way, just as easily. And when I say easily, I mean that you just give it a different parameter and you get a different build. I will now go and demonstrate this, hopefully, if things work. Right, let's go and share a screen. Here we go. Right, we're back on the terminal window. I'm hoping that this is going to be big enough. I may have to just bump the size up a little bit. So I've got a terminal here, and this is a directory that I've set. I will bump the window a little bit bigger in the hope that we can all see. Yeah, that looks better. I hope that's... yeah, a little bit more. That's that. There we go. Right. So we've got a demo directory here. I'm going to use a software project creation tool that I wrote called RISC OS Project. And all this does is it bundles together the bits that you would normally use for a for putting together an application, and makes something that you can use. Oops, typo that. So I'm building a test application. It's a command, and I want to have a skeleton out of it. Skeleton. There we go. Helps if you can spell, doesn't it? So this has created a make file, a C file, and a version num file. If you look at the C file, we can see it's just a simple script that goes, a simple main file that then goes and prints out some messages. So I will now go and build that. And it's built. There we are. So we can run it. Again, use Pyro to run this. Common means load shared C library and a few other things like floating point emulator and stuff. And I want to run AF32.test. There we go. Thank you very much. There's the output from my test program. So that was very simple. We can have a look at the binary. So if we have a look at the actual binary file here, we can see here that it is disassembled. It's an AF file. This is the disassembly of it. And you can see that here's the main function. It calls a printf, I assume that's printf, and passes these strings to it. And that's it. That's all it does. So I said we could build this as 64-bit. So let us do that. Build 64 equals 1. Here you go. It's now doing a 64-bit build of exactly the same thing. This time using GCC instead of Norcroft. And we can run this. Instead of common, we put 64 in there. And I want to run the 64-bit version. We have the same program run. If I try running the 32-bit version, I get an error message. They're not executable on this system because this system doesn't support it. At some point in the future, we may have an emulation layer or something else that allows us to do so, but that's what we do right now. And like we did with the 32-bit, we can see what the code looks like. So this is the 32-bit support side. So if you try to run it on a 32-bit system, it gives you these errors. And then the 64-bit stuff starts here at offset 100. And then if we have a look at the main function, this is the main function. It looks very similar. String, string, 2 printf functions, and then an exit. Thank you very much. You're wonderful. Much better. Excuse me. So, as you can see, it's really simple to switch from one implementation to another. If we have a look at the make file, you'll see it looks very similar to the make files that you have in ROUGOL's makefile system. It's not the same, but it's very, very similar. And the point of that is that we came from very similar sources. But there is nothing in here that defines anything to do with what the compiler is at all. So that's a command line tool, but what about modules? So let's create a new directory, module, and we'll run RISC OS project to create a module. Not that, we'll create a module instead, C module. Thank you. And again, we've got some source code there, C/module, and a very simple module initialization. It prints out a message, finalization prints out a message, and that's it. Nothing else. And again, we'll build it for 64-bit. We use CMunge. CMunge has been updated to support 64-bit builds, and so we can now go and run this module. So if I do pyrodev 64 and then drop to the command line, there we are. I can now load this module, rm64.test, and we've loaded a 64-bit module. It wasn't especially difficult to build that, and if I wanted to build it 32-bit, I just would take off the build 64 equals 1. I use the build environment in all my live coding to demonstrate how to use it and how flexible it can be, and the idea is that building any applications should be very simple out of this. Every now and then I get bitten by the fact that the C compiler I use doesn't support C99, but I'm used to handling those things. Other people probably won't care about that. But you don't have to use my tooling to do this. There's another C library called Archi SDK, which is intended for building for older systems, but is just as capable of building to use with modern systems as well. And I've updated this to support 64-bit as well. You'll find that on GitLab if you search for Archi SDK, and there are links to that in the end of the project, end of the presentation. So I've talked about building C code, which is great, but it's not everything. I did see that ROUGOL had released a Fortran compiler. Now, Fortran is a little bit alien, and I don't know Fortran. I really don't know Fortran. I have, however, managed to write hello world in it. So if we look here, this is hello world in Fortran 90. Yeah, that's all I know. But if I want to build something for Fortran, there we go, build Fortran code. It's got some overlong symbol names, that's fine. But then we can go and run it as well. Hello world, there we go. And then it'll go and run the Fortran program and prints out hello world. So we can now build Fortran programs on RISC OS 64 for RISC OS 64 as well. I hope somebody will find it useful because I don't see a point in Fortran these days, but just having the ability is what matters. Okay. So, whilst cross-compiling is good, it isn't important to have other languages because not everybody wants to write in those languages in C and in Fortran or to cross-compile. So it's useful to have languages that run on RISC OS itself. So I've also ported some other languages. We've got STL Basic, we've got My Basic. It's a simple basic, it's not very impressive. SED is actually a language. It is Turing complete. PocketPy is a small Python. It works quite well. Perl, I've ported Perl. I also ported Prolog, but mostly so that we had a functional language in there. I don't know Prolog anymore. I've ported Lua. It's only a rudimentary port and I want to get the RISC OS extensions in there, but I haven't. And PicOC. PicOC is a C interpreter, which is quite useful because you can call Swix in it. Berry is a little scripting language. And I've ported TCC, which is a C compiler. And that runs on RISC OS. And then, of course, there's the BBC Basic implementation that Steve Revel is working on. I've spoken to him and he's not ready to offer any progress statements or share it just yet. But he has been working on it. And as we heard at the London show, he's not going to do any more on it until he can get paid unless he can get paid for it. Excuse me. So I'll do a very quick demonstration of the languages as well. I am painfully aware that I'm taking time here. Here we go. Screen. So, do some demonstrations of languages. If we go into PocketPy here, this is the source to PocketPy, and I can have a look in the RISC OS directory, and we can run it. Thank you. Just let me give it a bit more memory. A bit more than that. I've not had any time with this particularly, so I'm not quite sure what it needs. So we can start PocketPy, which helps if you can spell. This is a Python. Print hello world. We get out hello world. Fair enough. Oops. Right, exit out of that. We can try PicOC. Oh, come on. There we go, right directory. RISC OS. PicOC is a C interpreter, so we can run that. pyrodev 64. Right, if we have a look in here, we've got an AIF64 directory, PicOC interactive, printf hello world. And for those of you that remember your SWI-call numbers, because I don't, SWI2 is write 0. So we should be able to do hello world like that, and we get out a hello world printed out. And then Lua. Lua, come on, where are you? There you are. RISC OS directory, please. Come on. AF. Ooh, no. AF64 Lua. I say this is a rudimentary port. I did this in like 3 hours, so it really doesn't do very much. I need to find the changes, which I think are in Paolo's repository for RISC OS, and then I can put in the system calls and things. But there you go. Lua is working. As of this afternoon, I managed to compile some Rust code and then link it into a program that then ran. However, I did it on the other computer and it was literally a real mess to get it to work, but it did work. So Rust is a possible language in the future as well that people will be able to use on RISC OS 64. Maybe even on 32 as well. I don't know how to make that work, but yeah, in the future. All of this means that there are a number of languages that will be available on day one for a 64-bit version of the operating system, which is quite important. Obviously they need work, but it is important nonetheless. Finally, this one here. Reshare. Thank you. Moving on to the conclusion, we'll wrap this up, please. So I've talked quite a bit about RISC OS Pyromaniac and what the project's evolved into. As you should all know by now, my motivation is to push RISC OS forwards, to encourage the community, to encourage other people to be able to do things and to give them the tools to do so. You've heard about what I've been doing, you've heard about where I see the problems and what I've been doing to try and address them. I've been offering plans for how 64-bit work can be progressed. I've communicated what I've been doing and given example code, outputs and videos. I've been explaining and documenting the technical details. I've been providing videos to show development and generate interest in the 64-bit work. And I've been providing tools and testing environments for people to use. I hope that this is encouraging to people and they'll get involved in developing RISC OS for the future. I can only ask for people to get involved and provide the tooling and guidance to them. Are you interested in being involved? Come talk to me. Come communicate. Spend some time on the forums to go and talk about the problems. I think we can do something. And doing something is much better than the nothing that we've had for a very long time. Thank you very much. That's the end of my wittering, end of my talking about things. It is time for some questions, which I've already got one of. Have I considered porting BBC Basic for Windows? BBC Basic for Windows is Richard Russell's, I believe. That's, I believe, GPL. Or it might be commercial. I knew there were some problems with it. Part of the issue with that is that BBC Basic for Windows is a quite different environment, so it doesn't necessarily work the same way. It could be made to work, I'm sure, but not me. The thing to remember is I'm only one person. We really need a lot of people to try and work on different areas because I can only do so much. I've got a full-time job. I've got a family now. I've got married. And so I do have some other commitments. And that's true of everybody I know. But yeah, that's one of the things.
The only reason I mentioned it is that I believe Richard doesn't have license permission to produce a version of BBC Basic for Windows for the ARM, because that was reserved by the BBC. But of course, that wouldn't affect producing it for the 64-bit side. So I'm not thinking of necessarily the Windows bit of it, because BBC Basic for Windows is just an implementation of BBC Basic with a lot of extra features.
I don't know. I mean, I know there's some issues there. I know that, for example, and I've made this mistake, you can't call it BBC Basic unless you're Richard Russell, because he's the only person that's got permission to call it BBC Basic. So I know there's a lot of things on there. That is definitely something that would need to be talked about and worked out. I mean, probably the best thing is we start talking about it being Acorn Basic or RISC OS Basic or something.
Well,
And
like
maybe that's the problem. I don't know. Go on.
yeah, well, luckily the word BBC Basic doesn't break any compatibility because we always use the word basic. So yes, we can also use Matrix Basic, which is available and can be compiled even already now straight on RISC OS. It's just RUGOL refusing to use that. There is, as mentioned by Brian, BBC Basic for STL, which is another one. There are plenty. One thing, Chas, I wanted to mention is because actually, one thing that I've noticed is not very, very long ago, but some times ago, I released a chat GPT for RISC OS. And I have to say that the number of people using it is quite large, has reached, I think it's past 300 users. One thing that has emerged by these AI tools is that a lot of people like to use AI tools because they don't want to be judged.
Yeah.
So I keep mentioning this. I think probably it's time also to change the tone on the forum if we want to have people more involved, because unfortunately, a lot of people will feel judged and therefore will say, you know what, you deal with this shit. Sorry for the term. Have fun. I can share live anytime you want, but OpenAI reports more than 300 users. So there is a lot of people trying to code on RISC OS, way more than what we see on the forum or even online.
I absolutely agree with you, and I think most of the people here would know of instances, and I'm sure that we ourselves have also been party to those instances at times. Some of that's frustration, some of it's just we don't know any better sometimes. But yes, the forum does have a odd attitude, and in particular, the forum has I'm going to say one-upmanship type attitude of, oh yes, but of course I've done this or whatever. And I'm very guilty of that, or similar things of like, oh, but you don't quite do it. Yeah, okay, I just want to solve the problem. That is a thing. I don't know how to solve that, and I think that is true of most social environments.
Oh yeah,
days.
Absolutely.
I mean, maybe some not necessarily moderation, but maybe something could happen there. That's not something that I can really offer much into, but I do agree with you that is another area that is of concern. And I know some of the people that have been problems in those areas have left, and that's sad because rather than them leaving and taking their expertise away, it would have been better if they'd stayed. But yeah. So Chris has just said, do you think AI could be used for anything useful? Now, obviously, Paolo's got that. I wanted to start building in part of the AI into the build environment to say, I'm trying to do this. Tell me what I need to do and things. I have written RISC OS functions in one of my modules. I asked AI to go and write me it, and it went, yeah, here's some things. And I went, well, that's wrong, but only trivially, twiddled it, and it was done. And I think that's the sort of thing, the places where it can really help.
Yeah, so the thing is this, I keep suggesting everybody, even people that knows how to code on RISC OS, please keep using OpenAI tools that are developed for RISC OS, because OpenAI is training their model from all that stuff. And a lot of the data that I inputted in that model is correct. So it's normal that ChatGPT is learning about RISC OS more and more and more, and now you can just go to ChatGPT and ask, and it's starting to make sense now. Before it had absolutely no way to do anything RISC OS a few years ago. So the more you use it, the more they see that RISC OS matters, because it's so statistics, guys. So the more we use it, the more it matters for them, the more they use that thing to train their model, the more you will have good results from AI. It's all statistics based. So if you want to make it useful, you got to use it. We have to basically force the training. Nobody will do it for us, because if nobody talks about something, OpenAI doesn't waste GPUs for it. That's the reality.
Makes sense, yeah.
So can it be useful? Yeah, if we keep using it, we keep making it better and better and better. Yes, of course, absolutely. The hate about AI comes, well, there is a part that is just emotional because people are afraid to lose their job, whatever. But there is the fact that the AI generates slopes. Now, to bring AI from 0 to 95% is not that difficult. The problem with AI precision is from that 95% to reach 100%. That's where we will never reach it. So one thing that AI can do really well already now, especially when trained well, is all boilerplate code. Now, for people that are not into software engineering, boilerplate code is like creating empty classes for you, but already with correct name, correct approach, correct structure, and develop that in like a blink of an eye. Sure, you still have to write the code inside of it. So yes, you still have to work on it, but all boilerplate code, the AI is already really, really good at it. All simple code, all simple programs. Another thing, I don't want to take this presentation because this is Jerv's, but remember that with tools like My Ultima, you can develop completely using AI and have absolutely no problems on RISC OS because the tool itself is fully managed code on RISC OS. It doesn't break RISC OS. The people that came at the show and saw me literally maltreating, mistreating my RISC OS system, and he was perfectly happy. Actually, it was more responsive than Windows because that's what true managed code gives you. Gives complete isolation of the application from the operating system. This is why ARM has developed the Realm architecture to completely isolate an application from the operating system itself. That's even faster because it's in hardware. But exactly, Chris, getting to 95%, it's already a lot of help. So it means that people like Chris, Charles, Andrew, they will take a lot of benefit from AI because they already know when the AI is making crazy stuff up. The beginner user will not. And so the beginner user will just try to copy that code and then will have troubles, which introduce the other thing. I think, Jeff, another problem that people will have, they saw your demo, which was absolutely beautiful, great presentation. I loved it. Thank you very much. But you showed when everything works. What people struggle with is not that. People struggle with is when things do not work. That's where you see the difference between an experienced developer vs non-experienced developer. One of the things that many people, for example, prize about Rust is that Rust tells you what you did wrong and how you can fix it. Which C, Fortran, BCPL, Lua, Python don't do, right?
So one of the things I've tried to make a particular part of what I do, and I do the live coding, is when I have made mistakes, I try to explain what has gone wrong and why it's gone wrong. So yeah, that doesn't help for many things, but that's one of the things I try to focus on because knowing how to handle when things go wrong is a big part of doing good development, or even doing bad development for that matter, but doing development full stop. It's really important to know how to handle those cases, particularly as you say when the compiler doesn't give you anything. I don't know if you've seen any of them, but I've been using the plugins for Sublime Text that actually put the error messages in line with the code. Makes it hugely easier. At my work, I actually have it all doing AI suggestions as I'm going through code. I write Terraform, I write SQL at work. So horrible stuff. But some of that is terrible. Some of it's awful code. Other times, and I'll just give a quick anecdote from something a couple of days ago. I was writing some SQL code, SQL, for those people that didn't know. And I've gone, I'd like to do this, but it doesn't work. What I should do is use this table to look things up and then look at it through this table. And I pressed return, and then the AI went, do you mean this? And I went, yes. Oh, that worked. Thank you very much. I literally just wrote a comment to say what I wanted to do, and I did not expect it to actually write me the code that was exactly right. I mean, it wasn't exactly right. It got one of the labels wrong. But it can do great work when it knows the domain. So
absolutely. Yeah, no, absolutely. So I think it's going to be very useful in such a small community because it can accelerate the productivity of the few developers left, making them look like they are 10, look like 100. But it needs still people that understand what the AI is doing. Unfortunately, it's not there to do the job for us, which is why I still consider the against AI emotional, because there is no way the AI can replace us. The advertisement that they are making on LinkedIn is all bollocks because they have to invest money in the infrastructure. Cloud computing, GPU has nothing to do with replacing people. They need cash to pay all the stuff. So can AI help RISC OS? I believe a lot, but we need to have an AI that knows RISC OS. That's the problem. And there are still a lot of weak spots. The documentation. I don't know, Charles. We discussed that a million times, but that's important because I try to extract paragraph and stuff, transform to a knowledge DB, but I still see that there is a lot of stuff that when I tested it doesn't work. So, and I'm alone doing this. So, if people can test it, but also when you test, let me know what didn't go well. Okay, because if you test it and it doesn't go well and you don't tell me, well,
it's not going to improve on its own.
Yeah, well, I wouldn't program RISC OS without it now, Paolo. I've put a little quote in this chat. I don't know if anyone recognizes it. It was a clip I took out of a computer magazine in 1969, I think. It might be 1970. It's a Dutchman, Dijkstra, I think it's Dutch.
Yeah, I thought I recognised it. Yes.
And I knew him as the inventor of top-down programming and other things. But yeah, he said that programming will remain very difficult because once we have freed ourselves from the circumstantial cumbersomeness. Now, in those days, that circumstantial cumbersome was writing on a piece of paper what you wanted, sending it next door to a bunch of girls who punched it into cards, and you got it back an hour later. Then you put it over the desk, and you got it back 3 hours later with a printout, and you think, bugger, I've made a mistake.
We've just moved that cumbersomeness.
So that's what he was talking about, the circumstantial cumbersomeness. For me, AI removes that circumstantial cumbersomeness of having to look up how to spell a keyword.
And maybe that's the thing. Maybe that's the way to try and encourage people, as Paolo was saying, you've been saying, to try and encourage people to try and do things on RISC OS by just trying stuff out. I mean, one of the fun things about development, but programming, is trying stuff out, finding stuff that works or finding stuff that doesn't, and finding weird things. That's also really fun. I do want to go back because I had some questions earlier that I missed whilst I was talking very quickly. So I just want to jump back. I'll have to scroll past it. Sorry, where was it? Something from Andrew. Andrew, yes, he says, I think I asked before on the live show, with your examples, it compiles showing Norcroft being used, but I thought you'd say you didn't have a 64-bit output from Norcroft. Right, so I will very quickly make the demonstrate what the difference is there. So, if I can go back to my program.
Thanks, Charles.
Yeah, that's all right. So, the environment we've got here, you can see there's a make file that's got, this is a AMU make file. So I am using AMU here. So if I use AMU, get rid of all the O files, there we go. If I run AMU normally, yes, we launch Norcroft. So this is running the Norcroft compiler to build this code, and it's using the Norcroft linker as well. Now, if I switch over to using build 64, we now use RISC OS 64. This is a wrapper, and this is all RISC OS 64 link is also a wrapper. They wrap around GCC, and they do work giving a very similar command line. So if you were to give, so if I actually run this here, the wrapper also understands RISC OS file name conventions as well. Go on, please work now. If you don't work now, I'll be cross. Thank you. It understands those conventions and translates them for you so you know the same things. Obviously, GCC won't do that, but the wrapper does. It also knows about certain warnings and things. So if you specify them in terms of Norcroft style, it'll go and translate them for you. And the same goes for some of this. Like, for example, here, this is a link, a wrapper around LD, and it's translated that and that and that into the right things. If I do, I can't what the variable is. That looks like it. Is that the right variable? I don't know. Let's see. This is going to tell me what it would have done behind the scenes. That's why. Right. All right. No, it's not because I've done something wrong. I can't remember how that works. I'm sorry. I'll have to look that one up. But oh, I know it is. Yes. If I drop into the shell. So all this is running in. I'm now running inside the Docker container, but I can see everything exactly like I did before. I can now do this command, and it'll now tell me what it's trying to do as it does that. So it replaces some of the file names around, and then it calls the command with a different syntax. That's basically what's going on. We're munging one form into another form to make it just work. Does that help answer your question?
Yes, it was the module example that caught my eye, but
yes, on the module. Jump out there. The module one.
I'm sorry to be pedantic. I was just
No, that's fine.
trying to thoroughly understand everything you were doing quite at speed.
I did it at speed, I admit. I looked at the time and went, ooh. So here, yes, we've got RISC.
Yeah, it was that Norcroft line in the middle there that threw me.
Yeah, so this is because in order to pass the CMHG file, we have to pass it through Norcroft to do this pre-processing. That's why. So back when John Tickett did the original work on CMunge for GCC, he did make it work with GCC, but I haven't got around to making that work with the 64-bit side of things. So I've just left it doing it that way. That is a fair point, and I should fix that.
No, it was just that I saw that and it threw me for a bit of a loop because of what you were saying earlier in the thing, and I was sort of, why is it using Norcroft as the module?
That does seem a bit odd. You might also see it'll generate the header as 32-bit as well because it makes no difference.
Okay, so it's just mystery solved.
Yeah, no problem.